Now we're going to go over what happens when you have special cases. So there's two special cases that we're going to look at, and we're going to talk about what that special case actually means in math. So the first one we're going to look at is, what does a no solution look like? What does it mean when our variable can't be anything to make that solution true? That's what no solution means. It's like it's a fake statement. So steps are the same. You have to distribute. So negative 4 times 2x is negative 8x. A negative 4 times a positive 1 is a negative 4. Negative 8x minus 2. Now, I want to move my variables to the right. So I take this negative 8x and do additive inverse. Add 8x on both sides. What happened? My variable term canceled out. It's gone. Remember, additive inverse says 0. It's not even an x. It's just gone. So that one's gone, and I have negative 4. Over here, this one's gone too. My variable term is canceled out, and I'm left with a negative 2. This is where you got to use some common sense. Does negative 4 equal negative 2? No, they're two different integers. They don't equal each other, so it's no solution. Okay, no solution. Over here on the right, we have infinite solution. So what does that look like? Well, I do the same thing. I distribute. I combine my like terms, so nothing, those can't be combined. Over here, I have negative 9x, and I have a 3 and a negative 8, which is negative 5. Now, I get my variables on the left-hand side, so I'm going to add 9x to both sides. And look what happens. That guy is gone. Additive inverse, he cancels out. I have a negative 5 left. Over here, additive inverse, it cancels out. I have a negative 5 left. So now you have to ask yourself, is this statement true? Does negative 5 equal negative 5? It does. So I have infinitely many solutions. That means no matter what value I plug in, it's going to be the same and make that equation true every single time. So here's what happens on infinite and no solution. On both of these, variable terms, and I want you to write this out loud and proud, my variable terms cancel out on both of them, okay? When variable terms cancel out, one of these guys is going on. Ask yourself, is this a true statement? No. If it is a false statement, it is no solution. If it is a true statement, it is infinitely many solutions. But in both of these situations, my variable term is gone, okay? Now, let's take a look at a couple more down here. I'm going to look at, let's look at 1, 3, and 4. Actually, we may do these all real quick together because I want you to see what happens. All right, so I'm going to distribute. I am going to go through these pretty fast. So I get 6x plus 2 minus 3x equals 6 plus 3x. Combine like terms, 3x plus 2 equals 6 plus 3x. Now, I know right away that 3x is the same on both sides, and I'm going to take it out by doing additive inverse. So I know that right away 2 equals 6. My variable terms have canceled out. This is a false statement, so there is no solution. Okay? Look at number 2. Distribute the 6 to get 12x, negative 36. Negative 7 times a negative 2x is 14x. Negative 7 times 4 is negative 28. I get my variable terms on the left, so I'm going to subtract 14x. And I get negative 2x minus 36 equals negative 28. Constant terms on the right. Negative 2x equals 14. And x equals negative 7. I can still get a solution. When you have equations, you have possibilities. It's either you're going to make a variable equal to a number, no solution, or infinitely many solutions. Those are the three things that are taking place. So this guy absolutely is, actually this is 8. I lied to you because 36 minus 28 is 8. My math was wrong, but I fixed it. Had I checked my answer, I know I would have gotten it wrong. So x equals -4, it is a solution. Okay, let's take a look at number 3. So the distributive property, I get 40x minus 24 equals -18x minus 24. I add 18x to both sides, and I get 58x minus 24 equals -24. I get my constant terms on my right, so I'm going to add 24 to both sides, and I get 58x equals, and this is where students make stuff up. 24 and -24 equals 0. 0 is still a real number. It's rational. It's an integer. It's whole, right? It is still a number. My variable term has not canceled out, so I have to keep going. When I divide both sides by 58, x then equals 0. You can get 0 as an answer. That's okay. Just because stuff cancels out does not mean it's no solution or infinitely many. The only time it's infinite many or no solution is when your variable term cancels out. I still have a variable term that never canceled out, okay? All right, and then last one we're going to do is number 4. So I get 3x minus 13 equals 7x plus 14. Distribute the -4. I'm going to combine like terms, nothing to combine over here. 7x and -4x is 3x. 14 and 28 is 52. And then I am 42. What is wrong with me today? 42. And then I'm going to bring my variable term to the left. My variable terms have canceled out, and I'm left with -13 equals 42. This is a false statement. A false statement is no solution. So in each of these 4 examples, no solution, infinitely many solutions, and then 2, x could be something. X can be 0. It can always be 0. 0 is a real number. It's rational. It's an integer. It's whole.